Teach me about the Great Lakes. Teach me about the Great Lakes. Welcome back to Teach Me About the Great Lakes, a twice monthly podcast in which I, a Great Lakes novice, get people who are smarter and harder working than I am to teach me all about the Great Lakes. My name is Stuart Carlton, and I work with Illinois Indiana Sea Grant at Purdue University. And I know a lot about the bruises that you get when your 3-year-old daughter pummels you over and over and over again while faking taking a nap. But I don't know a lot about the Great Lakes. And that's the point of this here podcast. I'm joined today, so lucky to be joined today by a good friend, Carolyn Foley, also with Illinois Indiana Sea Grant. Carolyn, what's up?
Not much. It is super snowy outside and it's very, very nice. I love snow. I'm one of those people who's like, it's super cold in March. That's awesome. And everybody else is frustrated. So how are you, Stuart?
I'm fine, but you know you're just doing this snow thing to troll me because, as I always say, we never get any snow in West Lafayette. We actually have a little bit now, just enough snow that we can't sled.
Oh.
It's like a taunting snow is what it is. And so that's what we got in West Lafayette. And it was 0 degrees today. So the nice thing about West Lafayette is I walk my kids to school. So I walked into school at, after our 2-hour delay in the 0 degree weather. And that was fun. I mean, a certain type of fun, which is to say not at all fun. And, but no snow. It's like I could have been sledding him to school, but nope.
Yeah, and that would have been easier to pull along. So one thing I do want to say, I never knew the 2-hour delay thing until I moved to Indiana. That was not something that I heard living like slightly farther north, not like super farther north, but it was always like you either have school or you don't have school. Actually, the popular thing was the school's open but the buses aren't running. And because I could walk to school, my mom was like, you are going to school. And so yeah. Probably is why I'm a responsible person today. But yeah, I was also
that why? Because you didn't have who knew?
Yeah.
Well, congrats to you on being responsible. And let me just send out the tweet. I forgot live now. And we'll get rolling. Well, actually, it's funny that you should talk about all this snow and everything and ice because we're here to talk. It's winter. Right, which in addition to being just devastatingly psychologically difficult in this area due to the lack of sun and the aforementioned cold and the complete lack of snow to temper the psychological difficulty, it's a time where the lakes get covered in ice, or at least they should get covered in ice. And so we're here to talk about lake ice. Was lake ice a thing for you growing up?
Yeah, I mean, it was sort of, you'd like watch the local streams and like try to figure out if you could go out on them. And then, you'd go to an arena and it was like perfect ice and you go out on like a river or something like that. It's like, it's lots of fun. But yeah, people would like shovel off spots to play hockey. And yes, so lake ice. And then also the other thing that's really, really cool is like the shelf ice along the beaches is so pretty. So yes.
So wait, hold on. So to play hockey, so you would have a lake and it would have enough ice, but it would just be but there'd be covered in snow, and so you'd have to snow shovel the lake to clear out a hockey rink.
Yeah.
What a world.
Yes. What a world. Person from Louisiana. Yes. All right.
All right. Well, let's just jump right to it. We're going to bring in our guest, and since he is a researcher, I think we all know what's about to happen. So let's just make it so. Researcher feature, a feature in which a researcher gonna teach us about the Great Lakes. Our guest today is James Kessler. He's a physical scientist with the NOAA Great Lakes Environmental Research Laboratory over in Ann Arbor, remote in Ann Arbor right now. Not that Ann Arbor is remote. Anyway, my point is, James is our guest. How's it going today, James?
It's going great. Excited to be here.
We're excited to have you. We are. So we saw you were talking about ice with some people. We said we want to talk about ice too. We've had an episode or two about ice, but it's really important right now. And specifically ice coverage, like in the Great Lakes, So this is an important thing that y'all measure every year, right? Is that what you'll do?
Yeah. So folks have, I not myself included, but folks have been measuring ice cover for almost 5 decades. So we have records going back to the 70s.
Across the whole Great Lakes, you guys have been measuring for 5 decades.
Correct.
That's awesome.
Obviously, it's gotten, that the forms of measurement have gotten, more frequent and a lot better over the years. But
Huh. So how do you measure ice coverage? I picture like satellite imagery. Do you do like automated, machine learning based detection or something? Or
Yes.
what's up with that?
So I have to give credit to our partner agencies that we work with, the U.S. National Ice Center and Canadian Ice Services. They do really the heavy lifting with, the processing of data for the observational data. And yeah, a lot of it's remote, satellites and planes in various parts of the electromagnetic spectrum. They have radar in the microwave, I believe, which can see through clouds, visible images. But they also have observations on the ground. We call them in situ observations. On board ships, and actually brave individuals that want to go out on the ice and drill holes in the ice and measure the thickness and concentration.
That's really cool. Okay, so let's back up for a second. Planes. So people are like flying over the lakes, and then they have just some like, is it kind of like a crop duster type plane, or is it like something else?
It's so I'm not really involved with the actual data retrieval, but that's my understanding of it. Yes. Planes with instruments on them, and the people on board are trained, are ice specialists.
That's really cool. Do people, like the people who go out and measure things, are they like volunteers that they can sign up to help out, or?
I hope so, because I would like to do that. I've never had that idea before.
There we go. Well, you see, you give a little something, you take a little something from the show. So that's interesting. So you have these Great Lakes ice measurements obtained kind of remotely and from the brave individuals who sneak out onto the ice. You see, I just envision cracks, like just instant cracks, and then you're in the ice and then you have drowned and you're like, well, that really wasn't worth it, but maybe not.
That's why you're trained. But anyway, yeah. Okay.
Well, I guess they turn, yeah, but ice is like terrifying to me. Like this idea of, because under it is very cold water. And I think I've only seen, because it wasn't something I had exposure to, because, nothing ice is over in New Orleans and southern Louisiana.
It should terrify you. That's the thing, is that, it's fragile and it's dangerous. People get stuck on the ice every year and, have to be rescued. So I think you have, not being from the Great Lakes region, you have the correct reaction to it, I think. And people here maybe don't.
All right. And
Carolyn does not. And James didn't say that. Carolyn said it.
No, but it was obvious to most people listening. So they go out on the ice. This is not on the list of stuff, but they go on the ice like they're on their truck. They're going to ice fish like in that Letterkenny or whatever, or they're going to snow shovel and play hockey. And then and the ice like breaks around them and they're stuck. Who comes and rescues? Is it like
stuck on ice floes? Yeah. If you just do some Google searches for Great Lakes ice stranded, you can find all sorts of reports, and the Coast Guard or local authorities have to rescue people.
I envision a pack of St. Bernards with the little thing around their neck, the little barrel or little fanny pack. Ice in the Great Lakes coverage. What is the coverage now? Like, is now kind of traditionally when it peaks, or when does it peak in terms of ice coverage?
So great questions. So talking about what's going on right now doesn't make a lot of sense without context, right? You talked about the historical data. So right now it's just about 25%, which is right on key with the average for this time of year. And I'll try to not throw too many numbers at you, because you can talk about each lake individually, right? Or you can talk about all the lakes combined. So that 25% was for all 5 lakes, and that the maximum actually typically doesn't occur until mid to late February, and that's on average about 50%. So we're on track sort of to hit that, but who knows? But we're only about halfway there, and it is pretty early in the season. As far as individual lakes, Lake Ontario, Michigan, and Huron are almost exactly equal to their historical averages for this time of year. Superior and Erie are both a little below average. Superior is about 10%, Erie is about 45%. And those 2 lakes are sort of on the opposite ends of the spectrum. And that's basically because Erie is so shallow that it has a really small amount of heat content, so it cools the fastest and freezes the earliest and probably the most. And Superior is just the opposite, right? It's so massive, so it takes so long to freeze. So yeah, I would say I've been calling this sort of a bizarrely average year, because we're sort of right on track. And it's not typical to be that way. So for context, if you look back through the 5 decades of data we have, on January 26th, it's been as high as about 80% or as low as about 5%. So that's, a huge variation that it's possible to be. And this year we just happen to be sort of right where that average falls.
So that's okay. You just said a whole bunch of stuff that's really, really cool. So 25% over the whole of the Great Lakes. And again, James just mentioned this, but we are recording this on January 26th of 2022. So you know kind of where we're saying. So that's really, really neat. I also I don't know why I'd never thought about this, but yeah, the concept that it's actually Lake Erie that freezes first. It makes a lot of sense given how little water it is. But like, if you follow Lake Superior on Twitter, they are like super like, I have the most ice, etc. And that's not necessarily the case, right? Because of a bunch of other hydrodynamics. That's really cool.
Well, Superior is big, so they might have the most ice if you're looking at, square area as opposed to percentage, maybe. I don't
know. Right. Cool.
And it has frozen over, I think, 100% or close to 100% in the past. Superior has.
That's bonkers.
And so the depth of the lake affects the amount of ice coverage or how quickly the ice gets there, right? Because essentially, if you're really deep, you have a big hot water bottle, roughly, or maybe not hot, but less cold water bottle. Yeah. What else influences like ice coverage and how much there is?
Yeah, so I mean, the primary drivers are probably what you would expect. Water temperature and air temperature, which are obviously closely related since they both sort of regulate each other. But there are also secondary influences, cloud cover and solar radiation. Even snow cover has an impact. Once there is ice, it can accumulate snow on top of it so that you have to shovel it off when you want to play hockey and whatnot. But that snow acts as an insulator. It actually has a higher albedo or reflectance than uncovered lake ice. So that's going to influence things as well.
Albedo. So that's how reflective it is. And so the more reflective it is, it more sunlight bounces off of it. And therefore...
Less heat,
because less of the heat's being absorbed, right? Got it. So if it looks like a duck and it floats... Anyway, okay.
I don't know the albedo of ducks.
The albedo effect. You know what? We'll put a link to that in our show notes, which you can find at teachmeaboutthegreatlakes.com/50, the number 50, because this is our 50th episode. We should have had like a thing. I don't even have like a buppa, do I?
I have no idea, but we shouldn't make James wait while you search for it.
That's probably true. That's what we got. All right. Yeah, I won't search for a new buppa, but in your mind, imagine that was a buppa. Buppa. Okay. Great. Anyway, but so over time, how is so when I hear this, I hear about heat mattering and I hear about, whether I'm immediately thinking there's a climate change story here. Is there kind of a climate change story with ice? Is like the amount of coverage. So my guess is, and you can tell me if this is right, is that, every year may vary, but in general, the amount of coverage is probably going down as the world warms. Is that what we're seeing or what?
Yeah. So in short, I would say that's correct. So as I was mentioning, we've got 5 decades of data, and that's, for each lake and for each point in time and each point in space. So it's tons of data to look at. But if we sort of try to simplify it and collapse it down a little bit, we can look at the annual maximum ice cover for each year. So that's what it sounds like, the highest percentage of ice cover for a given lake for a given year going through time. And if you look at that data, it's super high. There are super highs and super lows. It's very noisy. But there are trends that show us that maximum ice cover is decreasing. And it is different for each lake. Superior is decreasing by about 7% per decade, where Michigan is about half that, 3.5% per decade. And that's in regard to that annual maximum. I think the Great Lakes as a whole, I think it's somewhere in between. They're about 5% per decade. And those trends are what we call statistically significant, meaning that they're not due to random chance. They're meaningful trends.
Okay, so I just want to hop in because part of why I was like, whoa, at the beginning was like having 5 decades worth of data it's not super common in science, particularly when you're talking about analyzing trends. So that's part of what makes this really, really awesome is that you are more certain that this is a real thing. That's really, really cool.
Yeah, absolutely.
But think about, so quick clarification on percents, because this always confuses me with them. So it goes down, let's say 5% per year. So that means in year 1, it's 100%. In year 2, is it 95%? In year 3, 90? Or is it the kind of thing where, so is it absolute or relative percentage? Is it percentage points or what?
I usually try and clarify that, but then I just talk in circles and I think I confuse people. So thank you for asking. You're correct, and maybe I misspoke, but those percentages are per decade, not per year. If it was 101 decade, the next decade it would be 90 and so on. Yeah, they're absolute percentages.
Oh, wow. So that's even faster. Okay. Probably. But figure that out on your own, kids, and report back. Teach me about the Great Lakes at gmail.com. So what does this mean? Lower ice coverage, right? So what does this mean kind of long term? What effects do you expect to see, either ecologically or climatologically, depending on what specific parts that you know about?
I mean, as far as impacts, there are sort of pros and cons. There's a big commercial shipping industry in the Great Lakes. It's a multi-billion-dollar industry, and they're impeded by ice cover. So they like to have less ice cover. And the Coast Guard, who goes in and breaks the freighters free when they're stuck in the ice and clears the shipping channels, I mean, they also benefit from less ice cover. There's also, as we've already sort of discussed, there's a lot of people who like to go on the ice, and that's a big recreation and tourism aspect. I say on the physics side, I think your background is more in ecology, but I'm aware of microorganisms and fish that depend on the ice for food and for spawning. So that's really important. So when there's less ice, they don't have a place to do that. There's a complicated relationship between ice cover and evaporation, because ice cover prevents evaporation. It acts like a cap on the lake. But in order for the lakes to cool enough, in order to freeze, they need to cool through evaporation. So there's sort of a complicated relationship. And then along with the recreation aspect, there's also this big, I think, safety implication, as we were just talking about people getting stranded. And with less ice cover and a huge variation in ice cover, that gets tricky because people assume, oh, it's a certain time of the year, it's safe to go on the lake here, and maybe last year was different than this year, and you're going to find yourself needing to be rescued.
Oh, so what was once thick is now maybe a bit thinner, huh? Unlike me during the pandemic. But that's pretty significant then. And I'd like to point out, with all this climate stuff, it's really complicated. In that, there's going to be some benefit to some people or some industries, even though there's also a lot of sort of negative of it too. But the stuff is really complicated. And it reminds me of when we were speaking with Vidya Balasubramanyam, and she was talking about also this may be a chance to think about that, right? And think about structuring things in ways that are more justice oriented. But a lot of complicated stuff. So is this decreasing amount of ice over decades? Is that kind of baked in at this point because of climate stuff, or is there a way that it might get reversed?
Yeah, so I think we're still going to see high ice years going forward because of that variability that we talked about. If you check our website, you can see the annual maximum ice cover that I mentioned. You can see that as sort of a chart. You can see just in the past decade, we've had 3 super high ice years. So a lot of people see that and say, is it really changing? And that's why I think it's really important to use statistics to try and find the trend and see if there's a meaningful trend. As far as future impacts, I'll just say that, Earth is a system and that the lakes are regulating the air temperature and vice versa. So I'll kind of defer to climate scientists that are studying the atmosphere because those changes are going to directly influence the changes in the lakes.
Cool. So you mentioned some of the products that you have available on your website for people to look at. And so we can add some links to those to the show notes, which again is teachmeaboutthegreatlakes.com/50, right? But can you talk a little bit about who uses those products? Like what types of products do you have available? And then sort of, do you have a sense of who uses them?
Sure. So one thing that I think is really great and came to mind when we were talking about how this year compares to prior years are these what a lot of people call spaghetti plots, which are, you can think of as line plots with every year of ice cover data overlaid. So it looks like a mess of spaghetti because it's all these lines overlapping. But then in more bold lines, you can show this current year and then also the long-term average. So that gives you a sense of what's ice cover right now, what is it on average, and how high and low has it been at this point in the year, and also where are we headed. You can sort of take a guess looking at that. We also have, as I mentioned, spatial maps. So those, the other plots that I was talking about are collapsing an entire lake down to a single line and just calling it a percentage. But there's a lot more to the story than that. There's also the spatial distribution of ice cover. So we have spatial maps or charts and the data behind those if people actually want to really get into it. For any given day going back to 1973 when ice cover was observed. And it used to be bi-weekly, and more recently now it's actually daily. So that's sort of the historical. We also have today's, or depending on when you're looking, maybe yesterday's ice cover, which is provided by the National Ice Center. And then we also have a forecast for the next 3 days, soon to be 5 days. And that's from a model simulation. Obviously, it's a forecast. And if you want to know more about that, you can check out the Million Little Triangles episode that describes, among other things, the very complicated hydrodynamic and thermodynamic model, which is just basically the currents and temperatures of the lake, but that model has a ice component to it. So we're able to predict the ice cover, and then use the great charts that we have to sort of validate that model as well.
That's awesome.
You're more pro than we are, James.
Yeah.
That's at teachmeaboutthegreatlakes.com/34 with Dr. Eric Anderson, who is now with the Colorado School of Mines, but was with Calero at the time. And the Lakey Award winning Dr. Eric Anderson.
Yeah, and I was going to say that James Kessler is putting himself in line for a Lakey 2023 award for like Best Guest Award. I dropped the episode for you, Carolyn and Stuart, so thank you for that.
Yes.
We don't play favorites, but
there may be a special category of Lakeys for self-promotion. Yeah.
So, Carolyn, you also asked about users. So I don't want to miss that, because that's obviously important. We can make all these great products, but if nobody's using them, it's not that great. So I mean, there are just curious individuals. I'm surprised how many people just like to track this sort of thing, just sort of for fun. There's fishermen, coastal resiliency planners, the commercial shippers, and even, like I said, the Coast Guard. Obviously, some of these people are more interested in what's going on right now and the future. They don't care about what happened, 10 years ago necessarily, but variety of users for sure.
Right. Cool. Yeah. And I was also thinking, part of why I asked that question is because we get asked questions by like meteorologists all the time about like lake temperatures at a particular spot, and making these kind of, I like calling them spaghetti plots. I like that term. So we've had lots of requests for those. So it's really, really cool. And so again, we'll put some links so that people can have a look at what's available. But you talked about like all this massive data that you have available. You talked about some of the products that are available. James Kessler, is there a product that you would love to make if you could? It can be as crazy as you want because our show is weird. So is there anything that, like, if you could have a dream, like ice coverage predictor or whatever, what would it be?
Yeah. So, I do a lot of modeling in my work, and I've done it with the atmosphere or the lakes and ice cover, and even, the streams and runoff over the land, being able to connect the Earth system. So that information between all these different models can flow both ways. So there's a two-way arrow between all of those different components. We call this model coupling. And it's a dream because it's too complicated to implement right now. There's too many components. You're basically recreating the Earth system on computers. But a lot of them have been coupled. We're turning on the more important ones. So in an ideal world, Earth system model on the computer would be the same as the Earth system.
That's really, really cool. And then you would have perfect predictions and no one would ever complain.
Exactly.
Well, Stuart would still find a way to complain.
You're still approximating physics, so I don't know, maybe not.
And accurately describing things is not necessarily complaining. It's just an unusually clear view of life, I think, is how I would describe it. Well, this is really interesting, James, and I'm really glad to hear about lake ice and all the stuff that I've learned, but that's actually not why we invited you on Teach Me About the Great Lakes this week. The reason we invited you to Teach Me About the Great Lakes is to ask you two questions, and the first one is this. If you could choose to have a great donut for breakfast or a great sandwich for lunch, which would you choose?
Sandwich, definitely. The reasoning, donuts are great, but I feel like you're never satisfied after eating a donut. Like you maybe just want another donut. Where like when you eat a great sandwich, it's satisfying. You can just sit there and enjoy being full.
I agree. Nobody enjoys being full on too many donuts. I mean, you enjoy it during. It's kind of like martinis. It's fun during, but then there's the aftermath. Yeah, that's good. So when I go to Ann Arbor, right? You're in Ann Arbor. All right. So I'm going to go up to Ann Arbor and visit you and all these other people. Where should I go to get a really great sandwich?
So if burgers count as sandwiches, I would say Frida Batidos.
Frida Batidos.
Frida Batidos, two separate words. And it's not going to be your typical sandwich because they're, I think, self-described Cuban-inspired street food. So there's French fries on it, and it's this big greasy mess that's delicious. If burgers don't count, the backup is Seva, which is also vegetarian. So if you have both options.
Seva, like the sheep? Is that what you said?
Seva, S-E-V-A.
S-E-V-A. Oh,
they've been in Ann Arbor since like the 50s or 60s. Like they've been here for a super long time.
See, we don't have anything like exotic sounding in West Lafayette. So when you say, I'm like, well, Carolyn's giving you
I think maybe we did, but then it closed. Yeah. Anyway. But yeah, that's awesome.
That's exactly it. We did, but then it closed. That's great. The second question is this. Is there like a special place in the Great Lakes that you'd like to share with our audience? So one thing we try to do with this show is we try to build an appreciation for this amazing resource, right? And so one way to do that is by talking about places that are special. Is there one that you'd like to share with our audience?
Yeah, so I mean, really anywhere in the Keweenaw Peninsula is super special to me. I think it's like the coolest place on earth, and that's the peninsula that protrudes into the southern part of Lake Superior. Specifically, if I had to pick a place, maybe Calumet, which is like a little mining town that's in the Keweenaw Peninsula. There's super cool history. It's super remote. Definitely check it out.
Well, James Kessler, physical scientist with NOAA's Great Lakes Environmental Research Laboratory, and a disturbingly smooth guest who seems more professional than we are.
He absolutely is more professional than we are. Thank you, James.
Yeah. Well, at least me specifically. So I protest against that. But anyway, thank you so much for coming on and teaching us all about the Great Lakes.
Thanks for having me.
Yeah, what a super knowledgeable guy. Obviously, it's really important stuff. And I hate it when the physical scientists talk better than I do. It's just really frustrating.
What are you talking about? We want good science communicators.
I mean, that's true.
Yes.
But, yeah. I can have two feelings, I think. And so that's what I do is I have two feelings. No, it's a really fascinating topic. And lake ice is something that to me, I just, obviously it wasn't a thing. I know a little bit about like puddle ice and to hear about like even today, what y'all were talking about with the hockey and all that stuff and getting stranded. It didn't occur to me that it was a cultural resource, right? It just occurred to me to think about it in terms of, the physics and the ecology and stuff like that. But that cultural side, and it's interesting, and it's interesting to hear about the different ways that people use it too.
Yeah. And I mean, I think that it's just also really, really cool to watch the images. It's just it's like art where you're watching different things and that you see the different wind patterns and things like that. So even in terms of like interested, I think some people are interested just locally, but I don't know. People like me are like, whoa, that's just so cool. Yeah, you can edit that out if it's dumb, Quinn. Sorry.
No, keep it in. We're keeping it in. It all stays in except for the parts that we were cutting out. And no, that's absolutely true. And a lot of the imagery and stuff. And, it's another instance of of the importance of these long-term data sets, right? And those very often rely on government programs. And we, of course, as a federally funded program, or Teach Me About the Great Lakes is partially at least federally, we don't advocate for any specific policy. But without these long-term government resources, a lot of the stuff we talk about just doesn't get done. And so it's really neat. And those are really valuable data sets to see across decades.
Right. Or at least not with any kind of confidence. Like when I encourage people to go take a look at the images that James was talking about, because they are kind of bonkers how variable things can be. So, yeah. All right.
Yeah. And that's with these really great data too. Yeah. Anyway, great. Well, so we're going to do again. We haven't done this in a while. What did you learn today, Carolyn?
I am super ashamed to say that what I learned today, growing up on the edges of Lake Erie, I should have known this, but like that Lake Erie freezes first. That is just, I don't know why I never thought. I think it's because I don't often think about like the depth and things like that past its form. I mean, I've thought about waves and I've thought about stuff like that. So that's really, really cool to think that because it's smaller, it freezes first and covers kind of higher coverage.
No, that is really cool. And the thing I learned today, well, I mean, a lot of the stuff we're talking about getting stuck on the lace and how that's more hazardous now, or stuck on the ice, excuse me, which is terrifying. But it's the term spaghetti models, which anybody from the southeastern United States, that is a triggering term because that's what they use the spaghetti diagram when they're modeling hurricane paths. And so you're used to looking at the spaghetti diagram and then finding the European model and looking at the different model runs and all that stuff. And so they call that the spaghetti diagram too. So I hear that, but of course they use it for this as well.
Different applications.
Yeah. And this is not triggering in the same way. It doesn't make me worried that I'm going to have to evacuate. All right. Boy, I don't have any announcements. Do you have any announcements?
Are we ever going to do a book club episode?
I don't want to announce that because who knows?
Okay.
Right? Death and Life of the Great Lakes. We may do a book club episode. I was honestly hoping that it just went down the memory hole, but Carolyn decided that it was not going down the memory hole.
You can edit that out if you want.
That's
the only announcement we
fine.
had for a long time. But yeah, nope, no announcements.
No announcements. Well, you know what you can do? We're going to have a call to action. You see, we're building engagement. That's what you do in a podcast. I was reading all about this. We're building engagement. So how do you use lake ice, listener? Why don't you send us a tweet to the tweet
at Teach Great Lakes.
Thank you. Or an email to teachmeaboutthegreatlakes@gmail.com. Tell us a lake ice story or call the hotline and we'll put it on the air. You know, if you call us, or we'll read your story in there if you want, or if you don't want, you just want to inform us, that's cool too.
Yeah, we actually really like to hear from you. So
yeah, no, we do. We get email periodically and the occasional tweet, and it's super fun. And it helps us to build a better show, frankly, because it gives us a wider breadth of experiences to pull from as we think about what topics we want to talk about and the ways in which we want to talk about them.
Also, you could be talking about ice now, but remember, in just a few months, the ice will be gone again, and we will be out swimming and boating and fishing.
That we will. Well, we won't be swimming because the water is too cold to swim in the summer, but that's a different issue.
Yeah. All right.
Teach Me About the Great Lakes is brought to you by the fine people at Illinois Indiana Sea Grant, and we encourage you to check out the great work that we do at iiseagrant.org and at ILINSeagrant on Facebook, Twitter, and other social media. Probably Instagram. I don't think we have a TikTok. Should we have a TikTok?
No, there's been a hard pass on TikTok thus far.
There has been?
Yes.
Okay. I'm too old for it, so I just have to rely on you youngins to tell me if we should have a TikTok. And the answer is no. We don't have one. Don't even bother. Teach Me About the Great Lakes is produced by Hope Charters, Carolyn Foley, Megan Gunn, and Irene Miles. Ethan Chitty is our associate producer and our fixer. Our super fun podcast artwork, look at it right now, is by Joel Davenport, and the show is edited by the awesome Quinn Rose. You should check out her work at aspiringrobot.com. If you have a question or comment about the show or an ice story, send an email to teachmeaboutthegreatlakes@gmail.com or leave a message on our hotline, 765-496-IISG. That is 4474. Follow us on Twitter if you want. Teach Great Lakes. Follow us on Instagram. No, we don't have an Instagram. We just have a Twitter. Oh my God. Thanks for listening.
And keep grading those lakes.
And keep grading those lakes.
Also, you know what we forgot to say? Follow NOAA Glaral. They have an amazing social media presence.
Oh, well, you know what? You just said it.